from last year or some year over this material, and this is how well I expect you to know this information. So I want your flashcards set aside. I'm going to check those in a minute. I don't want anybody working on them now. Set your flashcards aside. Put them in a pile. I'm going to check them. We're looking at this practice quiz now.
Oh, it's a practice quiz.
And we are going to sketch this. Which function is this?
Exponential.
Yes. And the exponential, Abby, you remember what it looks like?
It goes up like.
It looks like this. So that's what I expect you to be able to sketch. The next one, which function is the next one? That's the absolute value. Everybody know the shape of the absolute value? It's a V. So very simply put, there it is. See, Gibran, this takes me 2 seconds.
Now, see, hold on. Now, you said it's a BFF quiz?
Yep.
So I need to use my BFF?
No.
So what?
Now, which function is this? What do we call this one? The square root function. You know what it looks like?
It like comes up.
That's right. That's
like
what
a
it looks like.
rainbow.
So, part 1, done. Now, part 2, I have drawn the picture, and you write the, or give me the name. Remember, on your flashcards, there are 3 pieces of information. Name, equation, picture. Okay? So part 1 here, you had to draw the picture. Now you have to write the name. So what's that first one? Logistic. Perfect. Logistic function. What's the second one?
Greatest integer.
Greatest integer. Good, Gibran. And what's C?
Squaring.
Squaring. That's right. That's the squaring function. All right? Done. This is not going to be a quiz that we're going to sit there for 15 minutes on. You know this or you don't. All right, part 3, now you're writing the equation. So what's the first one there? Y equals X. Y equals X. What's the second one?
Natural log.
Natural logarithm, so what would be the equation? ln x. Y equals ln x. Nope.
L.
ln. Y equals ln x. Natural logarithm. No, f of x is fine. I've been saying y. If you've been saying f of x, that's fine. Remember, they're interchangeable. Doesn't matter. And, oh, be careful. What's that last one? That's the cosine. Kids, the cosine and sine are both the waves. Okay? But the cosine has this point on the y-axis, and the sine has the origin. So this is the cosine. This is the sine.
Oh.
You got to keep those straight. That's probably the hardest one to keep straight. They have the same shape, the waves, but on the y-axis, if you're up one, that's the cosine. If you're at the origin, that's the sine. Now, how many BFFs are there? 12. I had you draw 3 graphs. I had you write 3 names. I had you write 3 equations. There's 3 left. What are the 3 BFFs that we haven't done already in these top problems? One is the sine.
Cubing.
One is the cubing function.
Identity. Logistic.
And one is the identity. No, we did the identity. So one is the sine, one is the cubing. What's the other one we're missing? The reciprocal. These are the 3. These are the 3 in the boxes here.
When it says draw and then or write the equation, I can just write sine.
Yep. You write y equals sine x. You gotta write the equation.
Well, I saw that.
Or name. I guess it does say sine. You can say sine. Yep.
Yep. Loophole, guys. Loophole. Found it.
All right, got it? All right, turn it over. Now will not be on your quiz. This is just some review stuff. I had a back side of the paper, so I thought, hey, let's just do some practice work. Thomas Berg, doesn't that sound like a great idea?
Are you?
Okay, Thomas Berg?
I say yeah.
Okay. Don't say it with so much enthusiasm. All right, here we go. Problem number 1. Find the domain. Do we know how to find domain?
Yeah, you have to
Yes, we do. You turned over, Katie Baumgartner?
Yes.
Okay, we're finding domain. What are the rules for domain?
All reals. What?
You can't have a negative under the radical, and you can't have a 0 in the denominator. So when I look at problem number A, I see right away that x minus 2 cannot be 0, so x can't be 2. Does everybody else see that? I also see that x plus 1 has to be bigger than or equal to 0, which means x has to be bigger than or equal to negative 1. So I have a 2-part answer. Katie Thomas, my 2 issues with domain are denominators and radicals, right? And this problem has both. So I need to pay attention. All right, how about the next problem, B? What about B?
Okay, do you need to square root it?
We're talking domain, Abby.
Oh, you did like take out and stuff?
Abby,
I
stop.
would gloss, never mind.
What? No. I just talked to Katie about this. Abby, what are the 2 things I have to worry about whenever I say domain? What are the 2 things I have to worry about? That's not acceptable. We talked about this over and over again. What are the 2 things? I just did it right here in this problem. What are the 2 things I have to worry about? What's this, Abby?
Sorry, wait, what?
What's this?
I don't know.
Where'd it come from in the problem?
The denominator.
And what about the denominator?
Oh, there's none.
It can't be 0. The denominator can't be 0. Look at problem B, Abby. Is there a denominator?
No.
No, so I don't need to worry about that. All right, what's the other thing I have to worry about, Abby?
Square root.
If it's under a radical, it has to be bigger than or equal to 0. Does this problem problem B, have a radical?
No.
Okay, so Abby, the only 2 things I have to worry about are denominators and radicals. If my problem doesn't have either one, what's my domain?
It's 1. Wait, what? All real.
All
There is
reals.
oh,
Thank
all
you,
real,
Katie.
sorry.
It's all real numbers.
Gosh. I'm not-
Abby, you gotta get it. You gotta get this straight. The denominator can't be 0. Under the radical has to be positive. Okay? If you don't have a denominator and you don't have a radical, then your domain is going to be all real numbers. All right, let's look at C.
You were there.
Let's look at C. You already write down the answer, Rocap? What'd you say? Okay, Rocap says the answer to C, which is this, he says x is greater than or equal to 5/2. Anybody want to agree with him?
Agreed.
And we know that because whatever is under the radical has to be bigger than or equal to 0. So if you just write that down and solve it, you get your domain. Very nicely done, Jack. Number 2. Find the horizontal, vertical asymptotes and holes.
can't equal 0.
What can't
The
equal 0?
denominator.
The denominator can't equal 0, which means I'm going to have a vertical asymptote at x equals -5. Remember, domain and vertical asymptotes go together. Whatever makes your denominator 0 is a vertical asymptote. Does this problem have a horizontal asymptote? Oh, yes it does. It has one. Where is the horizontal asymptote? At y equals 2. Very good. Does this problem have any holes? No. Because the only way you can get a hole is to do what? Cancel. Well, yeah, factor and cancel. If you can't factor and cancel, then you're not going to have any holes. And that's okay. You just don't have any. All right, let's look at B. We're just doing horizontal and vertical asymptotes. Okay? So horizontal, vertical, and holes. Here we go. What do you want to do first with this problem? Abby, we're going to let you redeem yourself. What do you do first with this problem?
The denominator can't equal 0.
True. Before I get to that point, though, what am I going to do before I get to there? You are exactly right, but I want to do something
Do
first.
you need a factor?
I need to factor everything. Okay? So the top factors and the bottom factors. Right? And what do I notice about that now, Jack?
You can cancel x plus 1.
I can cancel out the x plus 1s, and my new problem then is this. Now, what does it mean to me that I could cancel out an x plus 1? I'm going to have a hole. The hole is going to be where? I canceled out x plus 1, so the hole will be where x is -1. It's always the opposite. Now notice that the hole is a point though. So I've got the x is -1 and I got that from what I canceled. Where do I get the y part? I'm going to put it right in here, right? So -1 minus 5 and -1 minus 1.
Which reduces to 3 of them.
To 3. So my hole is at -1, comma 3. To get my y coordinate, I go back to my reduced problem and I just plug in my x. So -1 minus 5, -1 minus 1. And then I work that out.
Is it an open circle when we graph it?
And if you were graphing this, you would have an open circle at -1, 3. You would just have an open dot there. Instead of plotting a regular point, it would be an open point. Maya?
So your vertical asymptote is at toxic.
Yeah, we haven't gotten there yet. Yes, your vertical asymptote is where x is 1. Because, how do we get vertical asymptotes? Whatever makes the denominator 0. Yep. No, because -1 canceled out, so we have a hole there instead of a vertical asymptote. Now, what about a horizontal asymptote? Does this problem have a horizontal asymptote? Yes, it does. You have x over x. What does that reduce to? 1. So you have a horizontal asymptote at y equals 1. Maya?
When you're labeling your lines and how come you use equal and not over not equal to?
Well, the actual equation of the line is x equals 1. The fact that I put an asymptote there means that when I'm plotting points, I can't let x be 1. They mean the same thing. It's just the equation of the line is x equals 1, but when I put it in there, it tells me I can't use 1.
How is a horizontal
Okay, because when I do my horizontal asymptotes, remember, I look at the highest power of x in the problem. I never look at the numbers. I just look at the x's. So if I look at the original, it's x squared over x squared. If I look at the reduced problem, it's x over x. Either way, it works out to be 1. So you can look in both places. But you don't look at the numbers. The numbers are not part of that conversation. All right, next. Okay, we're looking at C. So we'll factor. Does anything cancel this time?
No, so you get.
Which simply means that I'm not going to have any holes. That's okay. Usually we don't. However, this tells me what about my vertical asymptotes? There's going to be 2 of them, and where will they be? X equals 2 and x equals -2. I'm going to have 2 vertical asymptotes. Right? Now, does this problem have a horizontal asymptote?
Yeah.
It's at 0, Olivia. You are exactly right. And for those of you who don't get that, think about it one of 2 ways. Either memorize that when the bottom power is bigger, your asymptote is going to be at 0. Just memorize that. Or figure it out by saying, hey, x squared is the biggest power, but I don't have one on the top. So I'm going to put a 0 x squared up there. Now I have 0 over 1, which is 0. So either way, think about it either way, but you got to know your asymptote's at 0. Katie, is your hand up?
Yeah. So when you don't have like 2 x's on the top, those kind of problems, like the denominator on that problem, you're not going to have any holes.
No, you don't have any holes because nothing cancels.
Oh.
If this had been an x plus 2, then that would cancel out and I'd have a hole there. But the only way to get holes is to cancel. So no canceling means no holes.
If your horizontal asymptote is 0, is that the x-axis?
It is the x-axis. So if I were graphing this one, I'd have a horizontal asymptote right there on the x-axis, and I'd have a vertical at 2 and a vertical at -2. All right, last one. Here we go, because we got other stuff we got to talk about today. Last one. What do you think?
Factor.
I'm going to have a vertical asymptote at, well, okay, let's factor. Does anything cancel when I factor? No. So I'm going to have no holes. I am going to have a vertical asymptote, though, aren't I? Where's my vertical asymptote? Oops. -1. Because where do vertical asymptotes come from? Denominator 0. How about a horizontal asymptote in this problem? There is none. Because either you memorize that when the power on top is bigger, there's no asymptote, or you recognize that, hey, I don't have an x squared in the bottom, so if I want to compare those, I have 1 over 0, which is undefined. So the only thing this problem has is a vertical asymptote at -1. All right, let me see your flashcards. Oh, I was sure everybody would have this assignment.
I got it.
All right, get those done.
No, those guys here. That,
Actually, I might.
you know, like when you just like look at someone and you're like, oh, okay, I'm afraid of you. That's how it is for all of them.
It might not be. It might as well go.
Okay, not guys.
Well, half credit, but do I just Thomas, where are yours? Okay, well, you were asking yesterday, but come on now, that's what we do all this crap online, so you know what you need to do. You have those done by tomorrow.
Yeah, but I have some, I just got 3 months, and then
Your assignment was to put on no cards, but put on paper. Yeah, and the directions were graph on one side, name on, and function, name and equation on the other side. Not stuff back to that. Yeah, like that. So Ethan,
or you just put them out for your own house.
yours are done.
Or your parents just like have your name.
Yours are done. All right,
My graphs
now,
are even good on the back, let's check it out.
we have 2 things that we have to accomplish today. All that we just did was review. We just reviewed, okay? Got caught up with stuff. Now what we need to do is look at 2 different ideas, and they're pretty simple ideas. I don't think you're going to have any issues with them, but we've got to talk about them. The first idea that we're going to talk about is you are going to be responsible, now not on tomorrow's quiz. Tomorrow's quiz is going to be like the one that we practiced, okay? You got to know names, shapes, and equations. The next quiz we take will involve having you sketch things like this. Okay, so you will notice that all of these problems involve one of your basic functions. This involves the exponential, this involves the absolute value, this involves the squaring, this involves the cubing. But I haven't given you just the plain equation, which is what you get on quiz tomorrow. What have I given you? I've given you the equation, but I stuck in some numbers, right? And we need to understand what impact those numbers have. So is everybody listening carefully as we're putting on our lotion and doing other assorted things? We have to listen carefully, okay? When you add or subtract a number at the end of the function, the result is different than if you add or subtract it directly to the x. Let me say that again. This problem is a perfect example. In this problem, I have added or subtracted directly to the x, and then I have also added or subtracted to the end of the function. These 2 numbers behave very differently. If you add or subtract directly to the x, okay, is everybody fully moisturized in the back row?
This is on the BFF sheet, right? Is that where we?
No,
This
she's.
is-
Oh, wait a second. Let me see. Good point. Katie, let me see.
Okay. I just want to make sure I was close.
I am, okay. I am now, you're right, I was off track a little bit. Let me talk about these 4. You don't even need to write these down. You can if you want. Then we're going to go to note sheet page 10. Okay? Note sheet page 10. But first I want to do these problems. Thank you, Katie, for focusing me back on task. I got excited. All right, I want you to pay attention here, and then we're going to go to our note sheet. When you add or subtract directly to the x, that is what we call a horizontal shift. Okay? It's going to shift the picture left and right. A +1 moves 1 unit to the left. A -1 moves 1 unit to the right. So any time that you have added or subtracted to the x itself, you're going to move left or right. A plus moves you left, a minus moves you right. You got to know that. Not for the quiz tomorrow, but for future. You got to know that. If you tack a number onto the end of the problem, it's not hooked to the x. It's not attached directly to the x. It's just stuck on the problem. That moves you up and down. It is called a vertical shift. A vertical shift. If it is a plus, it goes up. If it's a minus, it goes down.
Just forward. I thought negatives always went to the left.
That is very true.
Like for the horizontal shift, but no, it does not go to the left.
So what about gravity?
I appreciate you
I just-
thinking about that, but no. With x's, it's always the opposite of what you think. So +1 would seem like it would go right, but it actually goes left.
Just for
Now,
if I messed up.
these do what you think. So this is going to go down because it's a minus. It's going to go down too. But this goes left. So if I were going to graph this picture, and now think for a minute, it's a squaring function. So it would normally look like this. This is the shape you have memorized. But this one has been shifted 1 unit to the left and down 2. So it's going to be exactly the same picture, but 1 unit to the left and down 2.
So you know that these equations are now instructions on how to draw something.
Exactly. That's why we got to memorize them. Yep, you're right, exactly.
First I was trying to solve them. Now I
No, yes, no, we're sketching it. We're
I'm gonna
sketching
try
it.
some. I can do all.
All right, let's come over here to this one. Okay, I just need everybody paying attention. We're going to go to our note sheets in a minute. Everybody knows the shape of this curve, right? This is this one, your exponential. See that +1? It is not hooked to the x. It is just stuck on the end of the problem. And what does a number stuck on the end of the problem do? Moves you up or down. What does a +1 do? It takes this picture and moves you up 1 unit. So now it looks like that. Instead of having this be its asymptote, everything's picked up 1, and this would be the picture. Same picture, just moved up 1 unit. Look at this one. This is an absolute value. This is a normal absolute value, right? Look where that 1's attached. That 1 is attached directly to the x. It's not stuck out here, right? It's right on the x, which tells me that the picture is going to move sideways. Now, which way is it going to go? X minus 1. 1 unit to the right. So I'm going to take that v, and I'm going to move it over 1 unit to the right. Finally, this is our cubic function. Looks like that.
It's going to move over to the right.
What is that one going to do?
It's going to move
3 units to the right. Same shape, just pretend you could lift it off the page and position it over here. Now, Let's look at our note sheet, page 10.
Or did that exponent not?
The exponent tells me it's a cubing function.
Oh,
Over to the right, fine.
Okay, so here we go. We're on our note sheet now. We've done some background work. Take a look at the problem. Guys, where's that 5 attached? Is it attached directly to the x, or is it attached outside somewhere? To the x. That's a horizontal shift. It is an x minus 5. So a minus is going to move you to the right. So first of all, what does the normal square root look like? This. This is the normal square root. You got to know that tomorrow. This one is exactly the same thing, but it's moved over 5 units.
So not -5 units?
No, it's moved over to the right. We must learn this. Horizontal shift. Positive moves you left, minus moves you right. Now, first thing though, when you look at the problem, you got to figure out, is this horizontal or is this vertical? So you got to ask yourself, is this hooked right to the x, or is it stuck on the end of the problem? It's stuck on the end. This would be hooked right to the x, kids. Do you see the difference between that and this?
Yeah.
Okay, so that's a vertical shift. So that's going to take this picture and do what with it? Up 1. So what shape is that? A V. The normal absolute value would look like this. You're moving it up 1, so it's going to look like that. C I already did up here before. That happened to be one that I picked before. I'm going to erase this and hopefully you've got that down. What did we say e to the x plus 1 looks like? Up 1, there it is. It's your exponential moved up 1. What does D do?
The left one.
D goes left 1. Very, very good. What shape is it? Parabola, yep. So there's a picture of D. Tell me about E.
Goes down 1.
Goes down 1. It's the same parabola, but it goes down 1. How do we know it's a parabola?
Square.
The squaring function. And you're gonna got that memorized. That's on your note cards. All right, got it? Okay, what are the rules again? If it's hooked to the x, we go sideways. Plus goes sideways. Plus goes left, minus goes right. If it's tacked on the end, it's up and down. Plus goes up, minus goes down. Okay? Now, the last thing we have to do today is part 4. We have to sketch these dudes. Do you know what these are called?
This one, aren't you sketching it already?
What?
Aren't you sketching it?
Well, yes, but now number 4, look at those equations. Those are a little bit different. These are called piecewise functions. Does that sound familiar to you? And all that means is you have like two problems in one, and we're going to do it in pieces. If you allow this to be hard and confusing, I'm going to get angry at you. It looks hard. You want to impress your date, pull one of these out. This is impressive stuff.
Is that how you?
But it's really, really easy. All right, so we're going to look at this a piece at a time, piecewise, a piece at a time. Let's look at that top piece. Y equals the absolute value of x. Y equals absolute value of x. I'm only looking at the top piece. Everybody in this room should know what that looks like. What does that look like? It's a V. So I'm going to sketch that V, because that's what it looks like. Now, here's the problem. Right in here. Here's the problem. I'm not supposed to sketch the whole V. They tell me that I'm only to sketch the part of the V that has x coordinates bigger than 3. So I'm going to count over here on my graph. This is where x is 3. Would you agree with that? Now I'm going to run a little dashed line straight up to my curve. This is the point on the curve where x is 3. You need to understand that. This is the point on the curve where the x coordinate's 3. That splits my curve into two pieces. I have this piece, and then I have this piece. Which of the two pieces do I want? This tells me I want only the parts of the curve where x is bigger than 3. So is x bigger than 3 here or here? That way. So I erase this part of the curve. That's why we use pencil, so we can erase. I don't want the rest of that V. I only want the part of the V where the x's are bigger than 3. Got it, Bryce? Now, I'm going to put that on hold. I'm going to forget about that, and I'm going to look at this one now. Y equals x squared. That's a U. So I'm going to go ahead and put my U on my picture. Now you got me to do it. It's a parabola. I'm putting the parabola on the picture. Now again, I don't want the whole parabola. It tells me I only want the part where x is less than or equal to 3. So remember this dashed line we drew? I'm going to extend it up until I hit my parabola, which is going to be right here. And I'm going to put a closed dot there. Any ideas why I'm putting a closed dot on my parabola? Because they are equal to. And now I've got two pieces of the parabola. I've got that part shooting up, and I got all the rest of it. Which part do I want?
The other part.
I want the other part. I want the other side this time. So I'm going to erase this little thing I just drew. I'm going to erase my 3 line. And boys and girls, that is a picture of your piecewise function. They are weird looking things for sure, but they're easy to do if you do it a piece at a time. I'm going to do C real quick, and then we'll do B. All right, so let's look at our first equation, y equals x minus 2. Anybody know what shape that is?
Straight line.
a line. Now, that is your basic function, right? Y equals x.
Yeah, it's negative.
So now it's dropped down 2. We'll move it down 2. Right?
Yeah.
So I'm going to have a line that looks like this. Now that's the whole line. That's this whole line. What part of that line do I want? Where x is 0, this is where x is 0, right here, this is where x is 0. I want the part of it to the right. So I'm going to erase this part. Everybody good with an open dot there? What's my second equation? It's another line. This one has a slope of 3. So I'll just start here at the origin and count up 3 and over 1, up 3 and over 1 again, and I'm going to generate this line. It's so hard for me to draw lines that's what I get. Wait, do I want the whole thing?
No.
No, I want the part from 0 down, so I'm going to erase this, and there is that piecewise function. All right, quiz tomorrow. If you have not yet done your note cards, you get those done and bring them to me tomorrow. I want to see them.
Do we need our note cards to the quiz tomorrow?